Now let's talk about generators. Generators are very powerful tools that Python gives us with. They are based on the concept of iteration, as we said before, and they allow for coding patterns that combine elegance and efficiency. Generators are of two types: generator functions and generators expressions. Generator functions behave like regular functions in all respects, except for one difference. Instead of collecting results and returning them at once, they are automatically turned into iterators that yield results one at a time when you call next on them. Generators functions are automatically turned into their own iterators by Python. So let's create a new file called first.n_squares.manual.py. Okay, let's define a new function get squares gen. Okay, it will receive an n parameter. Then I wanna create a for inside x in range n, as you can expect, and inside I wanna say yield x with the power of 2, like this. Now I wanna say squares is equal to get squares gen 4. Okay, print squares. Let's execute it and let's see how it's working and by now. So chapter 5 first and you will see something like this, which is the object generators. In the line 6 I created a new generator object. It just in the following line, in line 7, I just printed it. But we are looking for the value. So for that, you need to print something like this, or use an extra function called next, like this. Okay, I wanna print it 4 times, and let's see what is printing now. Okay, we've got the generator object, then 0, 1, 4, and 9. What about if I iterate another one? I require another one. So in the last one, you've got it's rising and stop iteration exception. That's because the generator is exhausted. We printed 0, 1, 4, 9, which is 4 values. That was the quantity of values that we required in line 6. Okay. In the preceding code, each time we call next on the generated object, we either start it first next or make it resume from the last comprehension point, any other next. The first time we call next on it, we get 0, which is the square of 0. Then 1, then 4, then 9, and since the for loop stops after that, n is 4, then the generator naturally ends. A classic function would at that point just return none, but in order to comply with the iteration protocol, a generator will instead raise and stop iteration exception. This is a good option in order to save memory and time. Use generators function whenever possible. Additionally, when we write a generator function, Python automatically transforms it into an object that is very similar to an iterator. And when we call next generator, that code is performed in generator dot underline underline next underline underline and parentheses. Let's revisit the previous example about generating squares, and now try with in another way like this. Okay. In this case, I wanna say the squares dot next like this. Okay, let's try. Let's execute it again, and you will get the same result as the previous example. Nothing changed, just the way we're calling next. When we call generator.send, the value that we feed to send will be passed into that generator. Execution is resumed, and we can feed it via a yield expression. This is very complicated when explaining with words, so let's see an example. I want to create a new file called gen.send.py, and inside I want to define a function called counter. Okay, counter, I want to define a parameter star at 0 by default. Okay, inside of the counter function I'm gonna say n is equal to star, and now I wanna create a loop, a while loop, specifically saying true like this. Inside a while loop, I wanna say result equal to yield m like this. Print type result, and also the result itself. Then if result is equal to q like this, I'm gonna break the loop, and else I wanna add one unit to the counter. Okay, like this. Now I wanna say counter like this, and I wanna print it next C, next C, next C, but I wanna try something different here. I wanna say C dot send. I wanna send wow like this. Another case I wanna send Q. Okay, like this. Q exactly like this. Now I wanna run it, run terminal. I wanna look for a gen file. Okay, I'm gonna execute it. So what's going on here? First of all, we're defining a generator called C. Okay, with what's wrapped with a counter function. Okay, when we call next right here with our generator, it starts with a value of 0. Okay, and it's equal to 0 in the first execution right here. In this while loop, we are yielding in the first abstraction that value 0. That's the reason we are seeing for the line 12 that value 0. Okay. In the next execution, we are resume the application and we are sending also the string wow. So it resumed the application right here, and result obtain the value of wow, the string wow. That's the reason in the line 5 we are printing the type result and also the result itself, and we are seeing here class string and wow. Okay. We are continuing the application, result is different to Q, and we are adding 1 to the M value. So in the next execution, in the next yield, we are sending 1. That's the reason we are seeing 1 here. That's for this execution in line 13. For line 14, we continue the execution, but in this case we are done sending anything. That's the reason the result in this line is printing none type and none. Okay, none is different to Q, that's true, so we are adding 1 to the M value. It was 1 plus 1 is equal to 2, so that's the reason this loop restarted, and we are yielding 2 value here. In the last one, we are sending Q, a Q value. We result obtain the value of Q. It brings a string and also Q, but it breaks the execution. It breaks the loop, and we are done sending anything. That's the reason that we've got here an stop iteration, and also it's printing what instruction is causing that exception.